to Solving for the Undefined podcast. I'm your host, Johanna, founder of Miss Kuiper's Classroom, the place that equips teachers in creating a healthy math classroom where students can thrive, no matter their academic abilities. But it's not always about the numbers, and that's why I'm here, bringing you the formulas to solve your problems, math and otherwise, plus strategies on cultivating that necessary math mindset. And that's what you can count on.
All right. Hello. Welcome to a brand new episode. This one's going to be an exciting one because once again, I am doing a co-hosted episode, but this time I'm doing it with Kristen Moore. Hi, welcome.
Hey, thank you so much for having me. I'm so excited that we're getting together and sharing with both of our audiences about so many exciting things coming up. I think that you talk to such a great group of math educators, and I'm so pumped to be talking to you in real life right now.
I know it's so cool to always meet people I see on Instagram and social media and then finally meet them in more of a real life personal setting. It's always it just feels so cool. I feel like I'm meeting celebrities all the time.
Oh my gosh, I totally get that. I love what the internet has done for us in terms of connectivity to educators everywhere, because then you can learn from and meet the best people all over the place.
Yeah, it's pretty cool. Do you just want to share a little bit about yourself?
Yeah, absolutely. So if you don't know me, you guys, my name is Kristen Moore. I'm a high school math teacher and an instructional coach. And I'm a longtime believer that math is so much more than just solving for X. Hence my handle, right? I like to support students and teachers in growing in both their confidence and their capabilities with real, relevant, and rigorous projects in PBL. PBL is my passion. Bringing math to life is my passion. So that's a little bit about me.
I love that. That's so cool. I more than X. It makes sense with your last name and your whole thing of wanting to make sure that students understand more than just solving for something and seeing the whole picture. I like that.
Yeah, isn't it funny? I didn't even know my husband then, but I tell him that I leveled up. I clearly picked him just for the last name. It worked so well with how I was already teaching. So
That's perfect. I love that.
awesome.
So, we're talking today in this episode about how we can help students master math concepts. So, let's talk about why is it important to go beyond just memorization?
Yeah, I think that's huge, especially with the way that technology has advanced lately. There's no reason to have to memorize everything. It's right there in your pocket, at your fingertips. You can ask Chat GPT all of these things. Instead, I would so much rather our students be able to problem solve and identify those solutions, those models, those problems that they're thinking about to make sense of it and figure out if the solution that they find actually makes sense. So really, I think now it's more important to have a strong number sense and a capacity to reason and problem solve, even when the numbers are messy, right? Because eventually we get to, high school math. And then beyond that, the real world has messy numbers. None of it works out perfectly, friends. Right. So if they've got that strong number sense and that problem solving ability, they can find those patterns like we're talking about. That's really got to be the fundamental goal of our math programs right now.
I agree. I like what you said about being able to see if it's reasonable because there are so many times where students are given maybe a real world problem or a word problem where there is a number that would make sense for this scenario, but they get some number that just isn't reasonable for the scenario and they can't think about it. They don't know how to reason with it and problem solve oh, that doesn't make sense. Maybe I need to go back and look through it. But just memorizing that procedure or that algorithm isn't always going to give them what they need. And especially when they go into the non-academic world and go to a job, they're going to need more than just memorizing a bunch of data. They're going to need to know how to implement it and how to diversify it between different scenarios. So just teaching them to memorize something is doing them a disservice in the long run.
Totally agree. Procedures are important and you've got to be fluent with them enough to know that something's not reasonable. But you're right, we've got technology and we can look up formulas and things like that. In the real world, I look up real formulas. If I need to know what my kid's student loan rate is going to be, I don't sit there and crunch the numbers. I look up the formula and then I go, yes, that makes sense logically because I've done the procedures before and I've got that reasoning and number sense.
Yes, exactly. So let's talk about what are some ways to help students master math concepts rather than just like simple rote practice and skill drills.
Yeah. I mean, I think that those have had a purpose, and I can still see some value in them at times. And really, I'm like a huge proponent of PBL, but honestly, when it comes to procedural skills, that is not the best way. It's just not. It's my favorite way to teach, but it's not the best way. So if your standard is like procedurally focused, I would rather build that fluency from that conceptual understanding. It's something I learned when I taught computer science. Fun facts, I taught computer science for a couple of years. And it was like you do the activity before you learn the concept, and then you kind of play around with that concept before you get the vocab to go with it. It's really like an explore first, formalize later. If you're familiar at all with the mathematic approach, I love them. I'm also like a really big fan of thin slicing, right? Peter Liljedahl's work. I love that
Yes.
he gets the students to think either individually or as a group and kind of work their way through it. What do you think?
I love that. It thin slicing is something that I am new to, but I'm using in my classroom this year with my coworkers, and I love how when you're thin slicing a set of problems, it's stair stepping students slowly and gradually learning more and more deeply the understanding and figuring it out. So like the example they give in the book is multiplying binomials, I think,
Yep.
using the terminology I'm not entirely
Yes.
familiar with.
Nailed it.
Um, Thank you. And like the first one is using like easier numbers, and then it moves into like a bigger number, and then it adds a subtraction sign, and the next one is two subtraction signs. And it's just like slowly building their understanding of, well, you got this one, now do it again. It reminds me of those like weird workout programs where day one you do one squat, the next day you do two squats, and you're
Yeah.
slowly building your strength. It's like that. That's what thin slicing is. You're slowly building your stamina to understand whatever concept you're teaching.
Oh my gosh, I love that analogy so much. You're right. They're flexing that muscle, and I do love that in his approach he often will have them do like kind of two in a row that are pretty similar, and they're like, "Oh, okay, we figured it out. Oh, okay, we got it." And then he changes it just a little bit. I think that's so powerful in helping our students to get that practice in. And honestly, if my kids are doing a thin slice task up at like the whiteboards, they're going to do so much more procedural practice than they would if I were to just hand them a worksheet, which is just going to overwhelm them anyway, right? It's so much better to have them up there with their group of 3 or however many you end up, getting in your class. 3 is ideal, but they're going to do it better, and they're going to be able to reason and problem solve it together, which is so nice.
More minds are better than one.
Absolutely.
Yeah. I think another really cool way to help students master math concepts is through like manipulatives and discovering. At first, you kind of talked about that with the computer science class that you taught of like doing the exploratory first and then learning the vocab. I do this lesson with my students for geometric transformations where I give them 4 pictures and they don't know any of the vocab yet because transformations are a specific 8th grade topic. And they just describe it. What do you see? What do you notice? What do you wonder? And then from there, kind of giving them the opportunity to see each other's work. Like, oh, that makes sense that they use the word flip for that one, whereas we use like mirror. And then giving them the option, what I do is I'll give them the 4 transformation words. And based on what you and everyone else in the class came up with, what word might make sense for that picture, and it allows them to use like their real world understanding, because thinking about translation, if I'm speaking in English, a translation would be to Spanish, and it's just moving the word from one language to another. It's still the same object, but I'm just moving it. And you can do the same thing with like a an image on a graph if it just moves, and so
Yeah.
they can kind of reason through the words. And that's another way to help students just like bring their vernacular into it and then attach the academic term to that. And I feel like that makes it just stronger in the long run.
I totally agree. We're actually covering that in my Algebra 2 classroom right now. So I've told them, I'm like, guys, we're going to activate our prior knowledge back to all the way in middle school. So I'm really glad that I was telling them the truth when I told them they started talking about this in middle school. I'm like, we're going to look. I'm like, how did these two things change? And it was, I think it was using an activity from mathematic that I just mentioned where they're exploring like how a square root function is transformed, right? And so, yes, they're looking at functions and graphs, and that's a little bit different than looking at it as shapes, but they get that same opportunity to explore it as a concept first and use their own vocab with it. And then I'm able to say, like, okay, how did you guys describe this one? What happened here? And they're like, well, it kind of like it got skinnier this way and it did this. It kind of feels like it pulled. And I was like, great. And then somebody else is like, well, that's kind of a stretch. And someone's like, well, that's actually a dilation when you think about it this way. And I'm like, oh, look at all this vocab that you're connecting. It's so great for students to be able to work together and collaborate that way to really get that good conceptual understanding, right? That's where the procedural skill is going to come from, having a good conceptual foundation.
I love that. I love that they were able to pull from their prior knowledge to be able to come up with those words. Because for my students, when we talked about dilations. One of them called it Ant-Man because like Ant-Man gets bigger and smaller,
Oh, I
and so
love
then,
that.
yeah, isn't that so
So
cool?
good.
And so when we did that unit together and we like talked more specifically about dilations, I was able to bring that back up of like, oh, remember it's Ant-Man? And so like Ant-Man, his arms aren't going to be smaller when he gets bigger. Everything about him, it changes at the same rate. And so we were able to talk about proportionality, and I used words that students came up with. And I feel like using the vernacular and the words that students use, like for you, it was pull and stretch and dilation, using those in the lesson helps students like, oh yeah, I did come up with that. And I feel like it brings some ownership to it too, which helps students like feel engaged and more likely to master the concepts in the long run.
Absolutely.
So let's talk more about how we as teachers can foster that deep conceptual understanding.
Yeah, I think that we both just hinted at it, right? Like getting the students to talk and share their ideas. For me, I really like to create what I call an anchor activity that I use either at the beginning of a unit or at the beginning of a lesson, and it's just this like tangible kinesthetic activity that we all do together that the students are going to refer back to with me over and over again. It makes it a really sticky learning experience for us. It cements that like neural pathway. So with quadratics, right? That's projectile motion. Those are those U-shaped graphs that we've all had to study. And that can be really tricky for students to start visualizing algebra in a geometric plane. And so I don't know if kendamas were a big craze in your middle school. They were on fire in my high school like 3 years ago. I honestly wanted to get a toy box to put all the kendamas in. My students wouldn't put them down. But it led to that moment of like, okay, let's use this. And it's a game where you've got a wooden stick and you throw a ball up and down and it like lands right back on it, right? Like we've all
Uh-huh.
had games like that. But it's a great representation of quadratic motion. So I would have the students do this. They would all get to play with their kendama and somebody got to come to the front. And then we would all on our whiteboards trace like, what was the path of that? How did it go? And as they did that, then we could start adding those words to it. I was like, okay, where do you think the highest point of that was? Where do you think the lowest point was? What were like, how long was it in the air? And they would give it to me in their terms, right? Like you're saying. And then I would say, oh, great, the highest point, we actually call that the maximum. And actually, really, the point is called a vertex. And so we would just keep having that to refer back to. And every time we would learn something new, we could go back to that one anchor activity where all the concepts were embodied at once. And it just kept giving us that sticking point.
I love that. And you mentioned something, and I know you've talked about it on your podcast, but making it a sticky activity. Can you elaborate a little bit more on that?
Yeah. So sticky activities are the kinds of activities where, like I said, you're going to be coming back to them again and again. And so it's really important to make sure that these are like multi-sensory activities, that they are something that you intentionally refer back to and intentionally pull more and more information out of, because like I said, it's going to make that neural pathway connection that much stronger. So with my example of the kendama, originally they're just drawing that kind of quadratic shape and we're just labeling those couple of points, like what are the intercepts, what's the max and min. But as we learn more and more about it, I can have everyone, okay, let's look at this. And you can put it on an anchor chart, or you can, if it's an activity, you can just have them redraw it or whatever. And it's like, okay, now what if I wanted to know how high it was at this point? And they can go to their graph and they can look at it. And the more that they can interact with that one activity, the stickier it is and the longer that's in their neural pathways. And so the longer they're going to know that content.
That's really cool. I love that. I'd never heard it before you shared about it. And I love that idea of making it sticky and make it therefore stick in their brain longer, building that neural pathway. So cool.
Thanks.
I'm interrupting today's episode to ask you a vital question. Do you have the tools in your classroom for student success? Well, wonder no more, because I have a way for you to check your work. My new guide, 7 Math Teacher Must-Haves for Student Success, has the top 7 items you need in your classroom. From classroom staples to manipulatives that are often missed, this checklist will ensure that your students have a successful school year. Additionally, each item shows the best budget and splurge options. Download the 7 Math Teacher Must-Haves for Student Success after listening to today's episode by going to misskiper.com/guide.
So we've talked a little bit about conceptual development and some ways other than, just procedural practice, but what are some other ways that you think we can enhance student math mastery?
I feel like there are so many different ways, and some of them are kind of like buzzwords that you hear, like incorporating some more like real life applications and having students like critically think and problem solve, kind of like we talked about at the beginning. And one of my favorite ways to do it is through what like the discovery activities and helping students like have, I guess it would be in your language, like multisensory, like having a manipulative in your hands, moving it and creating some sort of image with it. And I love the idea of using for transformations, using like mirrors or I use post-it notes for like the reflections, or for translations we use a map and we actually use like our city map and figure out how far is it from here to the closest McDonald's, and using that like tangible item with something that they already know, I think is such a powerful tool to help enhance their math mastery, because they know what a mirror is, and if they put it on the axis, they can see what it looks like on the other side, and it just enhances what they already know.
I love that. I think so many times when people hear, using the appropriate tools strategically as one of the math practices, they instantly go to like, okay, well, can they use a calculator or can they use a graph? But there are so many more hands-on tools that we can, empower our students to learn how to use and master and work with so that they can be creative and flexible in that problem solving. So, using a mirror, like that's something they might actually have available to them when they aren't necessarily going to have, their protractor or whatever it is available to them. So teaching them how to model with the math and use different tools in a variety of contexts, I think is just such a powerful way to get them to really feel confident as problem solvers.
Yes. And today actually I came up with a new one. I was teaching one of my 7th graders. We were doing the graph of me from Rise Over Run.
Yeah.
And I love that activity so much. It creates such cool like abstract designs. But the student was having the trouble understanding that it created 1 point when you have like 11, 13. Like that's 1 point where 11 on the x-axis and 13 on the y-axis meet at 1 point.
Yes.
And so I found this, I don't even know what it's called. I think it's called an angle ruler, where it has 2 sides and it connects in the middle. And so it kind of hinges on 1 point, and I created a 90-degree angle with it and put it on the 11 for the x-axis and 13 on the y-axis, and the corner is on the point. And so she was able to see where it actually goes. And from there, she was able to move it around to do other points. And it was just like something in the moment I was like, oh, that would be a really cool idea to use. And it helped her visually see what I was talking about of the point is where the 11 and the 13 meet. So just random items that maybe aren't necessarily normal for the task can still help students visualize and understand math concepts.
Yeah, that's amazing. Like, what a great use of your resources, one, and like just to think about that tool as a way to use it also. And when you're working in the coordinate plane, or when you're working with some of these things that are kind of abstract to our students, we really need to help them make it concrete. And so you were able to help her make it concrete by giving her that, here's our horizontal and here's our vertical, and they meet at this one intersecting point, where otherwise they just might think a point is like a dot, or they might try to put it at the 11 and then at the 13. And honestly, I had students in my class trying to do that today in high school. So I love that. Think I'm going to steal it. I don't know that I have a ruler like that, but I definitely have some like pencils that we can hold up and visualize. So guys, you don't have to have fancy tools. You can do this with the things that are in your room to help them, manipulate, model, and use whatever tool they have strategically for them. That's a really great idea.
Yes, thank you. And I feel like you have some really cool ideas for or what you do in with your whole thing, like project-based learning. I feel like that's a huge way to enhance student math mastery.
Yeah. So PBL is for sure like my ride or die, tried and true favorite way to teach math. I just think that there's so much more to math than solving just that procedural problem. And what I really like about math is just like you were saying that you like the kind of like discovery based and the inquiry based, like PBL is really just designing a unit that is like longer, and it's all inquiry based. It's like, what's happening, how can I see this? And so it very much provides that opportunity for the students to start exploring with something first and then formalizing later. It gives us like a lot of opportunities to use anchor activities, right? Like I mentioned with that kendama. And so again, it gives those students like that strong foundation of the concepts before they have to get to the procedures, right? And then in using PBL, because when you design one, you really want to make sure that it not just addresses real world concepts, because honestly, like none of my kids are jumping off of, a skydiving in Acapulco or whatever the big textbook companies think my students are doing for their quadratics. That's not real life. So the key behind PBL is that it can't just be real, it also has to be relevant to your students. And so I know that you know how important it is to get to know your students, right? That's what these first few weeks are about, and then continuing to nurture those relationships. And as you do, you find out what's relevant to them, and you can design a really great PBL unit around that. And when you tap into something that's real and relevant, the students are so much more willing to do that rigorous work, to understand
Mhm.
where that formula came from, understand what they need to do with this graph, play with the messy numbers. They're not afraid of it because they really want to know. They're actually invested in the process.
I love that you brought that up, that it's not just about real life, it's what's relevant to students. Because I feel like that's a huge piece that's missing, just like you were saying in like a textbook. They're not always doing buying the stereotypical 64 watermelons from the grocery store. That's not relevant
No,
or real for most people. That'd be kind of crazy if it was relevant to you. I'd
right?
want to know more.
Right?
Uh but having that segue of, like, it's real life and it's relevant to your student's life, I feel like that's the sweet spot of truly digging in and having them engage more because they want to, and they feel like it's more tailored to them, and it's not some abstract concept. It's like, "Oh, that's totally what I do," and just
Yeah.
figuring more about it. I love that.
Yeah, I think that's the piece that a lot of people are missing. Or like if you just go get a random project, like, yes, it's a cool application, but is it getting that buy-in? Are you really getting what you want out of that time? And goodness knows we have so much content to cover and not enough time. So making sure that it's a good use of your time and that your students are really invested in it, I think is just key.
Yes, agreed. So, one last thing, talking about how educators can assess the understanding. Because if we're doing these creative discovery things, we want to still make sure that they're tied to what our students need to be learning. Like you said, we have so much to cover in a school year. How can we truly assess if students are understanding it versus just memorizing it? Regurgitation.
Oh, yeah, yeah, being those mimickers instead of those thinkers. I think that there's a time and place for every kind of assessment. I still use, like, I did mastery checks in my classroom today, and those are like 5 question homework quizzes. And I still use some traditional quizzes as well. But I think that performance tasks are super underrated. And even like those more dessert projects, like at the end, I think that those can be really well used to assess a student holistically, but you've got to come up with the right rubric. Like, I don't want a rubric for either of those things to be like, well, it was neat and it was colorful. That doesn't tell me anything about you as a mathematician. Instead, I like to use a three-prong approach. It's called model, solve, analyze. And my like forever favorite PLC partner, Liz Victor, and I are like, we don't even work together, but we collab on these regularly. I think yesterday I sent her one of these.
Nice.
And it's like, it's the whole modeling process. Like, how are you going to model? What kind of math do you want to use? Do you need a table? Do you need a graph? What are you going to do with these pieces? Can you identify what you need? And then, so you're hitting them applicably there. Then you're hitting them with the solve. Like, can they do the actual procedures that they need to get an answer and to get a correct answer? And then the analyze goes back to that conceptual development, which you and I have been talking about like this whole time, right? It's how well do they understand that concept? Does their answer make sense? What can they infer from this? So this like three-step approach, model, solve, analyze, is something that I think any teacher can take to any task. You could buy something off of TPT, recreate a better rubric, and get so much better information out of it than just, it was colorful and the graph was correct.
I love that because it's truly like digging at, do they understand it and know, like, do they understand it so well that they can do it in more than just one way of like they're able to understand it and analyze it and model it. And I think that's so necessary because when you go to a job, you're going to need to more than just, can you answer the phone call? Like, you're going to have to problem solve through that. And it's going to be more than just, did you do it right?
Yeah.
Did you use nice language? It's going to be so much more than that.
I love that you keep saying more than that. Like, that's literally my whole thing. I'm like, it's more than just this. It's more than just that. Like, you've got to put it all together. So, what do you think at the middle school level? What are you thinking about assessment strategies there?
We use a lot of rubrics as well, and specifically we use like the 4-point rubric
Hmm.
of, one, like they don't, it not seeming like they understand, and four, being able to justify and explain how they did it and why it works for their scenario.
Yeah.
Because sometimes students will get the right answer, but they don't know why they got the right answer, or then how to share it with someone like, oh, here's how I did it and why it works. And so we really push that understanding of, can I explain it to someone else? Because when you can teach it to someone else, and we know, as teachers know, like, we have to know the math so well in order to teach it. That's what we want for our students. We want to make sure that they can look at it, do the problem, come to an answer, make sure it's reasonable for the scenario, and then justify why it's correct. That's kind of where we are when we talk about, or when we do assessments for our students.
I love that. That's like building in the analyze right into your rubric. Like, great, you can get an answer, but do you also understand where it came from, why it makes sense, and why you would use this process? That's fantastic. I love using the like 1 through 4 rubrics and that mastery based model with students, regardless of how you end up having to put it in your gradebook. Like, right, everyone's got like traditional or weighted categories or standards based or comp based. I don't know, whatever you've got, but rubrics are so great. First of all, they're super equitable, right? Like, a rubric is a rubric. There's no like, well, your poster's really pretty and yours isn't that
Mhm.
pretty. There's none of that um, subjectivity. I'm
Mhm.
trying to think of the word. There's none of that in there. And then you're able to expand them and show them exactly what you want from them to push their thinking as a mathematician. So you're getting more out of them than you probably would have if you didn't have that 4 point and they thought they just needed that answer. That's so awesome.
Yeah, and it actually reminds me of, like, when I was a freshman in high school, I had this project where it was, like, a language arts project where we had to talk about, like, certain books from, like, a time period, and I don't remember the specifics, but I made a really cool project. Like, I made a 3D poster
Ooh.
bookshelf with, like, little books inside of it, and I got a C on the project because I didn't have what they wanted in it. And it goes to show, like, you can do a really cool presentation in a project, but if you don't know the math and you're not showing
Mhm.
why it works and you're not being able to analyze it, that's not going to get you very far.
Oh my gosh. That sounds like a cool project, and I'm so sad that you got a C, but that is a really good example, so thanks for being vulnerable and sharing that with all of us. I mean, our students gotta know that too, like, here was something I was super proud of, but guess what? Whoops, missed the mark, and here's why I did that, so don't let it happen to you.
Exactly. Exactly. So, kind of everything we've talked about, like mastering math concepts, there's something really cool coming up soon that Kristen is a part of with me. And I wanted to share a little bit more about it. And then I'll have Kristen share about what her specific role is within this. So, in October 20th through 23rd, I am hosting a math conference called Educator Exponential, where we are investigating the formula for math mastery. My priority with this conference is to share different ways to teach math concepts and help students discover, investigate, and have hands on learning. I want it to be more than just teaching practices that you can implement in your classroom. I want to help you find more ways to teach the math so your students can master the math concepts. So, Kristen, can you tell us what your presentation or your
Session?
whatever it's called
Yeah.
is in this
Yeah.
conference?
I am so excited to be a part of this. Getting our students to discover and investigate math is so crucial, right? Like that's what we've been talking about, and it's so helpful in getting them to master it. So, in my session, which I'm super excited for all of you to come and join, it's basically going to take us 15 minutes, and we are going to work side by side, me and you, our lovely listeners here. I'm going to guide you through creating your own PBL framework with 4 core components. PBL in and of itself can be a beast, but if you get started with just these 4 components, you've already gotten yourself well on your way to designing a gold standard aligned PBL unit. So you are going to get to work with me side by side, virtually recorded. I don't know, you can like pause me and do it with me, right? You're going to grab your pen, your paper, and follow along as I walk you through the exact process that I use when I go to design my own PBL units, thinking about those anchor activities and sticky lessons included. And I'm even going to walk you through one that I've designed and used in my classes that can be easily modified and used with all grade levels, right? Because it's kind of like a stats and data one that can be used with all the grades. So I'm super excited to get to share that with you guys and for all of you to get that framework so that you can see when a PBL unit might be a good fit for your classroom and you can walk through that process over and over again and just keep bringing the real world math to your students.
I'm so excited for this because I want to learn how to do that as well, implementing more project based learning for my students as well. So, if you, our listeners, are so excited to come to this conference, I want to share a little bit more. We have someone sharing about ratios, we have unit rate, integer operations, algebraic expressions, solving equations, geometric transformations, Pythagorean theorem, estimation, measurement, conceptual learning, and then project based learning. So, if you want to learn more about how to create these fun, engaging, investigative lessons using those different things, come to our conference, Educator Exponential, October 20th. It's free. I don't think I mentioned that part yet. It's free. So, please come share with all your teacher friends. We would be so excited to have you join us.
Absolutely. And then, keep the conversation going with us. Once you join, share about it with your friends on Instagram, invite more of your teacher besties because we want to share this math goodness with everyone.
Yes. Oh, everyone, all the people, all the math teachers in the world, you should be at this conference. One last thing that I always ask in every episode is what is your favorite math related joke or pun?
Okay, I love this. I've been waiting for this because I do listen and I've got some that are great shirts, but like they're visual and I'm like, what do I need? Okay. So, we all know Einstein. Yes?
Mhm.
Perfect. He's the founder of a lot of things. He's the originator of a lot of things. Did you know that he was the original rapper?
No, I didn't.
Oh yeah, his name? It was MC squared.
That's awesome.
Oh, it's so bad. I love it though.
That is
I
good. I've never heard that one. I love it when I always hear new ones. That's
right?
so cool.
Yeah. And I mean, now everyone's going to want to go listen to a little MC Hammer, dig out a little bit of Einstein. You don't know.
There you go.
There you go,
Nice.
guys. Your new task. Go register for Educator Exponential and go put on some MC Hammer. Perfect.
There you go. Perfect. That's the great way to end the episode. So go ahead and tell us where people can find you to learn more.
All right. So if you need to connect with me, you can find me on all socials at More Than Just X. And if you're catching this episode on Johanna's podcast, then you can also make sure to tune into my podcast, Modern Math Teacher. It airs every Tuesday.
Awesome. And you can find me at Miss Kuiper on Instagram and all the social media, or on Teachers Pay Teachers at Miss Kuiper's Classroom. And then if you're listening on Kristen's podcast, you can come join the conversation at my podcast, Solving for the Undefined. And my episodes drop every Monday.
Excellent. So it's a 2-for. Monday, Tuesday, you guys get some really good math knowledge dropped right to your ears every single morning. And that's the best way to start the week. So we can't wait for you guys to listen in and to chat with you as you come to our conference.
Exactly. Thank you so much for doing this. This was a fun adventure.
Oh, I have loved co-hosting this episode with you. Thank you so much, Johanna, for thinking of it. This was a great idea.
Thank you so much for tuning into today's episode. To find all the links and resources to things talked about in this episode, head on over to MissKuipersClassroom.com and click on podcast.